Okay, so in this video we're going to talk about some different bones of the appendicular skeleton, particularly the bones of the upper limb. So we're going to start here with the pectoral girdle bones, which include your clavicle and your scapula. That forms the pectoral girdle. This bone is just your clavicle. Ultimately the clavicle connects to your sternum and your scapula, but as far as the practical goes, you just need to know that this bone here is the clavicle. Now, the clavicle articulates with this bone, which is the scapula, and this is also the articulation point or connection point for your humerus, which is your upper arm bone, and that's going to connect over here. Now, in terms of structures here on the scapula, we can see, for one, the humerus articulates with this little fossa here called the glenoid fossa, or glenoid cavity. And this forms the articulation point for the humerus on the scapula. Some other structures we have nearby would be like your coracoid process. Coracoid means crow's beak, because apparently this looks like a crow's beak, but this is the coracoid process of the scapula. Something else that's nearby is the acromion process. The reason why it's called the acromion, if you all remember from body parts, the acromion was your shoulder, and this is the bone that really forms the point of your shoulder there. So this is the acromion process. This also forms the articulation point for the clavicle. Now the acromion process kind of leads into this spine here. This is called the spine of the scapula. This also serves as an attachment point for some various muscles. We also want to know the fossa that are nearby the spine. So the fossa here that's above the spine of the scapula, right here, is called the supraspinous fossa because it's above the spine. So supraspinous fossa. This one down here is the infraspinous fossa because it's below the spine and it's a fossa. So infraspinous fossa, supraspinous fossa. Now on the anterior side of the scapula, it's pretty smooth over here. This is going to be adjacent to your ribs. This is called the subscapular fossa, and it serves as an attachment point for a large muscle. That's actually it for the scapula. So what we're going to do next is move on to the humerus. Now remember, the humerus is a bone that articulates with the scapula. So the head of the humerus here articulates with the glenoid fossa or cavity of the scapula. We're going to talk more about the humerus here. So I'm going to lay it down on the table so we can see it a little better. And so the humerus is a long bone. So we have epiphyses and a shaft, or diaphysis. And so for what we need to know the humerus, well, this is the head of the humerus. And the head of the humerus is this kind of smooth articulating surface for basically your shoulder joint. Some other structures we find near the head would be the lesser tubercle of the humerus and the greater tubercle of the humerus, which is more lateral and kind of larger. And there's a little space here between the two tubercles called the intertubercular groove or sulcus. So lesser tubercle, greater tubercle, this is the intertubercular groove or sulcus. Now, this part of the humerus is the shaft, or diaphysis, and at the distal end of the humerus, we have a lot of structures here to identify. This large sort of protrusion out here is called the medial epicondyle because it's found on the medial side of the humerus, and it also serves as an attachment point for a lot of different muscles. Now, this is clinically relevant because there's a nerve that runs nearby called the ulnar nerve right next to the medial epicondyle. And this is also why it's your funny bone, because when you hit your elbow, it's right by that nerve, and it hurts. But the ulnar nerve would run right by that medial epicondyle. Now, right next to the medial epicondyle, we have the trochlea, which is this sort of large, sort of sharp projection here. The trochlea serves as the articulating point or connecting point for the ulna. Next to that, we have the capitulum, which is more blunt than the trochlea, so it's a little more rounded. And this serves as the articulating point or connecting point for the radius. Now, on the posterior side of the humerus, we can see some other structures like this large cavity. Remember, the posterior side of the humerus. This is called the olecranon fossa because the olecranon process of the ulna fits right into this fossa when your elbow is extended. Now, what we're going to do next is actually move on to talk about the structure of the ulna. And we can see that the ulna articulates with the humerus there. And so remember, the ulna articulates with the trochlea of the humerus. So if we look at the structure here of the ulna, this C here is called the trochlear notch of the ulna. And the reason why it's called the trochlear notch of the ulna, well, this is where it articulates with the trochlea of the humerus. Now there's some different structures here that form this C. This sort of inferior sharp point is called the coronoid process of the ulna. This larger projection up here is called the olecranon process of the ulna. And the olecranon process is basically your elbow. So that's the olecranon process of the ulna. Remember, the olecranon process is what would fit into the olecranon fossa of the humerus. We also have a shaft on the ulna, just like we have a shaft on the humerus. Now at the distal end of the ulna, this small projection here is called the styloid process of the ulna. This serves as an articulation point for some muscles of your forearm to move your wrist around, or to move your forearm. Now the ulna and the radius articulate or connect, and where they articulate is like this. Okay, now this happens to be a different side. This happens to be a left radius with a right ulna, so they don't match up entirely, but they would kind of connect like this. Now what that means then is that the head of the radius articulates with the ulna at this point, and actually kind of pivots and rotates around the ulna. So when you rotate your wrist, it actually rotates like this on your forearm. Now if we look at the structure here of the radius, we have a head, a shaft, and also a styloid process. So just like on the ulna, we have a styloid process of the radius, which is this sort of sharp point. And again, this serves as an articulation point for some different muscles. Now, it's the radius that mostly articulates with your carpal bones or wrist bones. So if I pull over an example of a hand here, what we see is the radius and the ulna. Now the radius is on the thumb side, ulna is on the pinky side, and that's an easy way to remember it. So if you think about your own hand here, this would be the radius on the thumb side, ulna is on the pinky side, so they're easy to differentiate that way. Now the radius forms most of the articulation point with your carpal bones or wrist bones, which we can see here. Now for the carpal bones, there's about 8 of them, and a good way to remember them is they occur in 2 rows. So we have a proximal row here and a distal row out here. The proximal row is made up of your scaphoid, your lunate, your triquetrum, and your pisiform. Okay, so scaphoid, lunate, triquetrum, pisiform. That's our first row. Then our second row is back on the same side, trapezium, trapezoid, capitate, hamate. So I always start with the scaphoid, lunate, triquetrum, pisiform, trapezium, trapezoid, capitate, hamate. And hamate's identifiable because it has that hook. So that's the hook of the hamate there. Now, for the rest of the hand, near the carpals, we have the metacarpals. The metacarpals really form the bones of your actual hand itself. And the metacarpals are numbered 1 through 5. The first metacarpal is over here by your thumb. And you go 1, 2, 3, 4, 5. Each metacarpal is associated with a phalange, which is basically a finger. And your first phalange here is your thumb. And it only has 2 bones that make up that particular phalange. So we have a proximal and distal phalanx, which form your thumb here. The proximal phalanx is here. And the reason why it's called a proximal phalanx, well, it's proximal because it's closest to the first metacarpal. So the proximal phalanx, distal phalanx of your pollex, or thumb. And then the other digits go 2, 3, 4, 5. And for the other digits, or phalanges, those have 3 bones. So we have proximal, middle, and distal phalanx, which together make up the whole phalange. So this would be the proximal phalanx of the second digit, or second phalange. And that's it.